Welcome back. Now, our goal for this bird pawn is to be able to steer it so we can fly in any direction we like. And in order to do that, we're going to make use of our controller. So thus far, we know that we have a bird pawn called BP Bird. And we know that as soon as we start playing the game, a controller is spawned for us by default. And because we've configured our bird to be possessed by the first controller in the world, which is the only controller in our case, we know that at the beginning of the game, our controller will possess the bird. And this allows us to add movement input, and we know that our BP bird will take that movement input and move forward, thanks to our move forward axis mapping. Now, we can create axis mappings for mouse input. As we move the mouse, we can harness that data and use it to rotate our bird. Now, the way that this is typically done is we make use of our controller. You see, the controller class in Unreal Engine, based on a controller, does not have its own location. However, it does have a rotation. Now, our controller is invisible. It doesn't have any mesh, so it really doesn't make any sense to have a location, or a scale for that matter. But it can have a rotation, and the rotation is often used for things like mouse input. We can take our mouse and move it, and thanks to axis mappings, we can have a callback function that takes that movement input information of the mouse, and we can use it to affect the rotation of our controller, which is an F-rotator. So being an F-rotator, our controller's rotation has its own pitch, yaw, and roll, and we can change those. And the functions to do that exist on the pawn class. We have add controller pitch input, which allows us to add pitch input to the rotation of our controller. There exist functions for adding controller yaw and roll input as well. Now, we're not too concerned with roll, but pitch and yaw are interesting for us because if we can change our controller's yaw and pitch, then perhaps we can use the controller's yaw and pitch and see if we can get our bird to rotate along with the controller. So the controller is sort of like a master rotation that our bird pawn's components can follow. So let's see how this works. Now, the first thing we should do is create some axis mappings. So we can go to Edit and Project Settings and scroll down to Input, where we see our axis mappings here. And we only have one, Move Forward, mapping our W and S keys. But we'd like a couple new axis mappings now, so we can take input from the mouse. So next to axis mappings, we're going to hit the plus icon, and I'm going to call this new axis mapping turn. Now we need to select what type of input our turn axis mapping will take. So I'm going to click the drop down and expand mouse, and here we have mouse X and mouse Y. Now to turn, I want to rotate our bird left and right about the Z axis. For this, we're going to use our mouse X axis, and this particular type of input provides us with information when we're moving the mouse left and right. So let's see how this axis mapping works by going into Bird and going into the event graph. And we can access this axis mapping value by right-clicking and typing turn. Now, scrolling up, we have axis events and axis values. Notice axis events has the arrow next to the turn, and if we click that, we have an actual event. Now remember, axis mappings are evaluated every single frame, just like the tick function. So this input axis turn event was created as soon as we created our turn axis mapping. And if we place an implementation here for input axis turn, it will be executed every single frame. And we can prove this by using print string. Now, print string is going to show us a message every single frame. We can take our axis value and plug it straight in to the in-string input for print string. And this way, it will be spamming the screen with string messages, showing us the axis value as we have converted our axis value from a float into a string. Let's just compile and hit play and see what this looks like. Now, here is what we get printed to the screen. And as I mentioned, we're spamming the screen. Now, if I click in the viewport to gain control and move my mouse to the left, notice we're not getting zeros anymore. We're getting values. And if we move to the right, we're getting other values. If we move our mouse to the right, we're getting positive values here. And if we move to the left, we're getting negative values. Now, what are these values? These values correspond to how quickly we're moving the mouse. So if I move the mouse really fast to the right, we're getting larger values. And if I move really fast to the left, we're getting larger negative values. So this gives us a great idea of how quickly we're moving the mouse from left to right. I'm going to Shift Escape to end that session. And back here in the event graph, we can see how to use this axis value to rotate something, such as our controller. Now, let's go ahead and remove the print string. And instead, I'm going to right-click and use the built-in function called Add Controller Yaw Input. So let's get that node and hook it up to input axis turn. And we can take our axis value and plug it straight into the value input. So Add Controller Yaw Input is going to add to our controller's yaw rotation. Now, our controller is invisible, so just rotating our controller isn't really going to do anything that we can see. If I click and move my mouse to the left and right, nothing happens. But here's the value of using our controller's rotation. We can actually make our bird pawn follow this rotation yaw. And to do that, we're going to click on BP Bird Self and type in yaw. And notice there's a variable here called Use Controller Rotation Yaw. And if we hover over it, it says, if true, this pawn's yaw will be updated to match the controller's control rotation yaw if controlled by a player controller. So if we click true here and press play, now our pawn is actually using that yaw. And as you can see, our character itself, which has a root component, that's the capsule, it's moving along with our controller now. It's following the controller's yaw. Now we can see our capsule moving as well if we hit the tilde key on our keyboard and type show collision. This is a console command, and if we hit enter, now we can see all the collision in the world. This includes the collision for our other geometry as well. But what I'm interested in is looking at our capsule. Notice our capsule is moving along with our controller. And because all of the components in our pawn are attached to the capsule, this includes our mesh, our camera boom spring arm, and the camera itself. They're all moving along with our controller. So everything is rotating as we change our controller's rotation. And the controller provides us with one single component that we can rotate to control the rest of our pawn. So this is very useful. Let's hit Shift Escape. So now we have a way to change the yaw of our entire pawn by simply changing the yaw of the controller itself and using this Use Controller Rotation Yaw variable. Now we can clear the filter on the search bar, and we see under pawn that Use Controller Rotation Yaw is not the only variable. We have Use Controller Rotation Pitch and Use Controller Rotation Roll. Now, as I mentioned, we're not interested in changing the roll, but the pitch we can change. Let's see what happens if we change the controller's pitch. Now, in order to do that, we need another axis mapping. So back in Project Settings, we can add another one. So next to Axis Mappings, let's click plus and make another axis mapping. I'm going to call this Look Up. And we'll hit the drop down here and expand Mouse, and this time we'll choose Mouse Y. Mouse Y is similar to Mouse X, only our axis values change when we move the mouse up and down. So let's see how this works. We'll go back to BP Bird and right-click and type Look Up. And we'll have an axis event called Look Up that was created as soon as we made that axis mapping. Now we can drag off of this and type Add Controller Pitch Input. And just like we did with our turn axis mapping, we're going to take that axis value and plug it straight in. Now, if we select BP Bird Self, we can enable our pawn to use the controller's rotation pitch. So let's check that checkbox and press play. And now if we move our mouse up and down, we're actually changing the pitch of our controller. And because our pawn is set to use that controller pitch, it's moving as well. So we can now fly up and we can fly down. Now, when I move the mouse down physically, I'm looking up. And when I move the mouse up physically, I'm looking down. So this is sort of inverted to what I would expect. Some people prefer this configuration, but it's a little bit less intuitive. So that's where our scale comes in for our axis mapping. Let's Shift Escape and go back to project settings. And for lookup, we can change our scale. Instead of 1, we can use -1. And this will essentially scale our axis value, which we're using to pass into add controller pitch input. So where it was positive before, it will now be negative. And if we press play, we'll see now that if I move my mouse up, I'm looking up. And if I move it down, I'm looking down. And this feels a bit more intuitive. So now we have control and we can fly around anywhere we like. Now, it's a little strange having our camera raised like this. And this is personal preference, but I'd like to take my camera spring arm, called Camera Boom, and zero out its rotation. So we have it set to -40. And if I enter rotation mode, I can rotate this camera boom anywhere I like, but I'd like it to be down like this with a rotation of 0. In fact, hitting the curved arrow will set it back to exactly 0, 0, 0. That's its default value. And now pressing play, I'm looking at the bird straight from the back. And this allows me to have the view from that angle. Now, again, this is personal preference. You don't have to do it this way. But this allows us to fly the bird around. And now we have the ability to steer. And we can fly anywhere we like. This is great. Now, we've done this in Blueprints, but we want to do this from C++. So instead of simply using the event graph with these nodes, we're going to do this in C++ now. So we can take these nodes and delete them. And instead, we're going to bind some C++ functions as callbacks to our new axis mappings, turn and look up. So let's jump back into Visual Studio. And here in bird.h, here's our move forward callback. We're going to make turn and look up callbacks. So we'll make a void function here in the protected section called turn. And just like move forward, it's going to take a float called value. Remember, the input axis event called turn in Blueprints had access to this value called float as well. We're also going to make another function called look up. And we're going to use a float called value in this one as well. So we can go ahead and define these new functions. I'm going to hover over and click the screwdriver icon and create a definition of turn. So we have that. I'm also going to make a definition for lookup. So we have that as well. Now that we have these functions, we need to bind them to our axis mappings. And we do that here in Setup Player Input component. So first we'll bind to our turn axis mapping. And we'll do that by taking our player input component, input parameter, and calling bind axis. And we'll do this just like we did for move forward. We'll pass in an f name, and we have to specify the name of the axis mapping, which is turn. Next, we have the user object, which is still this. And next, we need the address of the callback function. So we'll use the address of operator, followed by a bird, :turn. So now our turn function, which is still empty, is bound to the turn axis mapping. And we'll do the same thing for lookup. So I can go ahead and just copy this line and paste it and change that string called turn to look up. And again, this has to be exactly the same as the name of our axis mapping, case sensitive and all. And the callback function is not going to be turn, but rather look up. So now that our callbacks are bound to the axis mappings, we can program what happens in these functions. And we know that we simply want to add controller input. So we're going to call add controller yaw input, passing in value, just like we did in Blueprints. And for lookup, we're going to call add controller pitch input. And we'll pass in value here. So now we're doing this from C++. Let's go ahead and click Save All. And back here in the editor, we'll hot reload. All right, so after live coding, we can press play, and we see that we're changing the controller yaw and pitch, this time from C++. This is great. Now we have the ability to steer. Now, I do feel like I could angle my camera boom up just a bit, perhaps only 10 degrees. That way I can at least see down on the bird a little bit. And this feels great. Now, the cool thing about the bird is we can use it to sort of get a bird's eye view on the level that we're in. So while this level is quite boring, we can take a look at our open level and fly our bird around in there. So let's do that. I'm going to go to Maps and open my /open world and save everything before I go in there, of course. Now, I have some bookmarks, and if I press 1, that takes me over here to my forest. Here's where I'd like to start my bird so I can fly around the forest and see how beautiful it is. So I'm going to go ahead and go into Blueprints, Pawns, and get my BP bird and bring it in here. And I can go ahead and raise it up a bit. And I know that Auto Possess Player should be set to Player 0 now. So if I click Details and search for Auto Possess Player, I see that it's set to Player 0. And that's thanks to the fact that we added this in the constructor in C++. So I should just be able to press play and I'm good to go. So if I press play, I'm now possessing my bird. And I'm going to go ahead and hit F11. Now I have a full screen view. And I can go ahead and fly around and take a look at this. This looks amazing. Now you're going to notice something. We're going to fly straight through the ground if we try to. And that's because our capsule actually isn't doing anything for us by the way of collision. And that's because by default, our capsule is not set to collide with anything. Now it does collide with the trees, at least those that are set to block all, because that's the default behavior for those trees. They block everything. But our capsule is not set to block our landscape, for example. Now we can change that. I'm going to hit Shift Escape and go back into my BP Bird blueprint. Now I do need to hit F11. Now here in BP Bird, I can select my capsule. And capsules have a collision section in the Details panel. And if I scroll down to Collision, we have some settings here. Now, we're going to cover collision in great detail in this course. We don't know anything about it yet. But notice under Collision, we have Collision Presets. And this has a drop-down. Now, by default, it's set to Overlap All Dynamic. But if we change this to Block All, now our capsule is set to block everything. And now if we go back into our open world map, we can go back to where our BP bird is. So I'm going to search for BP_bird, select that and hit F. So I'm focused in on it. Now I'm in the same region, and if I press play, I'm possessing my bird, and if I try to fly into the ground, I'll collide with it. I will not be able to go through the ground. So that's a little bit more appropriate. Now I can hit F11 and get full screen, and clicking to regain control, I can fly around in the level. And this is great. Now we can sort of see what the level looks like, and instead of flying around this invisible default pawn, we're flying an actual bird, and that's a little bit more natural for flying behavior. This is awesome. And now we have this bird pawn. This is really cool. So we can fly throughout the level, see what it looks like, and we're not constrained by gravity as we have the ability to fly high above our world and get our literal bird's eye view. Awesome. Now, if we fly far away from our bird's starting point and press play from here, you'll notice that we don't actually possess the bird. And that's because we're starting off in a location far enough away from the bird that it's not relevant to us. Now, later on, we'll learn how to make sure that we start in a particular location in the map. But for now, we do need to be in the same vicinity of the bird when we press play. So if I select the bird and focus on it, if I press play from here, I will possess the bird because we're close enough that we're in the same vicinity. And you need to keep in mind that open world levels are massive. So we're not always loading in the entire level all at the same time. We're loading in only those sections that are relevant to us, and that's because we can't just load the entire level when we press play. So that's something to keep in mind. Now, before we wrap up this video, I'm going to show you something a little interesting and kind of strange. Let's press play. And as soon as we press play, we can turn around, and you might see something like a gray sphere. And if you play test enough, you may find one of these in your level. Now, You may be thinking, well, that looks an awful lot like the default pawn. And if you hit Shift F1 to get your mouse cursor back and detach with the detach icon, you can select that sphere. And in the outliner, you'll see that it is in fact a default pawn. So why are we getting this default pawn when we're supposed to be possessing our bird? And in fact, we are possessing the bird by default. Well, the reason for this is because our project is configured to spawn this pawn. And we can see that if we go to Edit and Project Settings. And in Project Settings, there's a section called Maps and Modes. And in Maps and Modes, we see that there's a default game mode. Now, we haven't talked about game modes yet. We'll get there. But our project is set to use this game mode. It's called Game Mode Base. Now, when our project has a game mode set for its default game mode, then our world is going to use it. Now, you can click on World Settings, and there's a game mode section here. And you'll see that game mode override is set to none. Now, if we set this to a particular game mode, it would override the project's settings game mode. But if we don't set it here, then the default behavior for this level is to use the project's game mode. Now, we'll learn more about game modes in the future, but one of the things a game mode can do is specify some default classes that our game uses. One of those is called default pawn class. And you'll see that Game Mode Base, which is a C++ class, has default pawn set for the default pawn class. So since we don't have anything set here for game mode override, this level is defaulting to use the game mode called Game Mode Base, which is set here in default game mode for our overall project. And because of that, we're spawning a default pawn. So that's why we're getting this default pawn being spawned in our world. Later, we'll learn how to create our own game mode and specify the pawn that should be spawned by default for us. But until then, just understand that this is why we have the default pawn here, even though we're not possessing it, as we've configured our bird to be possessed by the first player controller. And if we reattach, we'll see that we're controlling the bird, not that default pawn. So that's why we have that in our world. But don't worry. That's not permanent. Later, we'll learn how to get rid of it. So excellent job. We're now adding controller rotation input, and we've set our pawn to follow the rotation of the controller. And now as we move our mouse and move that controller, the rotation of our pawn will follow. And that includes all components attached to our pawn's root component. Excellent job. I'll see you in the next lecture.